Hi, welcome to the Water and Resource Recovery Center. I'm Willie O'Brien, plant manager of our facility. And we are here today to give a little tour of our facility and talk about the processes that it takes to take the wastewater, so that water that leaves your home that people have used for showering, bathing, in your sink, whatever it be, how that comes to our facility, how we treat it, and then safely discharge it back into the environment. Once the wastewater leaves your home, it flows through a sewer lateral, by gravity, out to the street where you would find a manhole. That manhole is connected to a sewer main, so the wastewater will continue flowing by gravity through those mains until it gets to a low point where we have what is called a lift station. A lift station is a pumping station that takes that sewage that comes in by gravity and pumps it under pressure eventually to our facility here. Because Dubuque is so hilly, we have a number of lift stations around town. We are responsible for maintaining about 20 of those larger lift stations. All of the wastewater that is conveyed to our facility is pumped here by 3 major lift stations. We have the Catfish Creek lift station just over by the Mines of Spain that pushes wastewater to our facility. That lift station serves the west and south ends of town. Then we have 2 major lift stations, the Terminal Street lift station, which is located under the Julian Dubuque Bridge, and the Cedar Street lift station, which is located down by the B branch. And those both pump through a 42-inch force main that runs along the river and up the valley here to our facility. We are standing at what we call the headworks of the facility. All the wastewater that's produced by the City of Dubuque flows to our plant here under pressure through these 2 force main pipes. We have a 18-inch force main and a 42-inch force main conveying that wastewater to the plant. On a typical day, we see about 7 million gallons of wastewater entering our facility. It comes through these 2 force main pipes, goes through what we call a magnetic flow meter. The actual flow rate is measured, and we use that information to run some of our processes in the plant here. So once we enter the plant, we go into what's called preliminary treatment. Preliminary treatment is removal of any inorganic materials which we don't want in the process. They won't break down, so we try to get them out of the process as soon as we can. The first part of preliminary treatment is called screening. So we are using what is called a bar screen to remove the larger debris. So it could be rags, plastics, pieces of wood, all kinds of things that come down to our facility that we don't want in the process. We want to get those out as soon as we can. Once the larger inorganic material is screened out of the wastewater, those screenings go into what's called a washer compactor. So they are washed to get any remaining organic materials off of the screenings. They're compacted and then conveyed to a dumpster that eventually goes to landfill. After the screening, we go to grit removal. So the wastewater goes through what's called a vortex grit removal system. So it's a large tank the wastewater flows into. There is a motor and a propeller that keeps that wastewater swirling at a constant speed, which is fast enough to keep the organic material suspended, and the heavier grit, or like sand type material, settles out to the bottom of that tank. From there, that grit is pumped to what we call a grit washer. The grit washer rinses off the grit, takes the organic materials, dumps them back into the forward flow stream, and then that grit gets augered to a dumpster, and which eventually goes to landfill. And as I mentioned before, typically we see about 7 million gallons of wastewater come in each day. The amount of inorganic material that goes to landfill is probably one 20-yard roll-off dumpster per every 4 to 6 weeks, I would say. So really not a lot of inorganic material that comes in for the quantity of wastewater that we're receiving daily. After preliminary treatment, we enter what is called primary treatment. So right behind me here is what we refer to as a primary clarifier. The primary clarification process consists mainly of settling. So the wastewater enters the clarifier through a tube in the bottom, gets dispersed throughout the clarifier. It has about 2 hours of what we call detention time, so that's enough time to dissipate the energy of that in the water and allows these heavier organic materials to settle out to the bottom and be collected as what we call primary sludge. So the partially cleaned water, we refer to that as supernatant or primary effluent. So that makes its way down to the next process, activated sludge process. We also have some skimming. You can see the arms that are circulating around the primary clarifier. They pick up any what we call scum, and that is removed from the process. Both the primary sludge and the scum from the top of the primary clarifiers is conveyed to what we call the blended sludge tank, and the blended sludge is the feedstock for the anaerobic digestion process. Behind me we have our blended sludge tank. Blended sludge is the feedstock for our anaerobic digestion process, and it consists of primary sludge, thickened waste activated sludge, fog, so that is fats, oils, and grease from restaurants. We also take some high strength waste from industry, and that is all placed into this tank behind me, and that becomes the feedstock for our anaerobic digestion process. In addition to wastewater flowing into our facility through the collection system, we also take septic waste that is hauled in on a truck. So behind me we have what is called our septic receiving station, and we charge a fee per gallon for that waste that people would want to bring here and have properly disposed of. So a truck comes in, hooks up to our system, we measure the quantity of septic waste on their vehicle and then charge them based on that quantity. This septic receiving station has screening and grit removal built into it, so then the flow doesn't go directly into our headworks, but it's pumped in just before the primary clarification process. Behind me we have our excess flow equalization basins. We utilize these in heavy rain events. When we get big downpours, we get a lot of what is called I&I, inflow and infiltration. So this is groundwater, stormwater that infiltrates into the sanitary sewer. It could be through cracked pipes, misaligned pipes. If there are tree roots growing into pipes and create a pathway for that water to enter, they will. Also, if people, any homes would have a downspout or a sump pump hooked into the sanitary sewer, that can contribute extra flow. So, as I said earlier, on a typical day we would see about 7 million gallons come in, but in a heavy rain event we can see 2, 3, 4 times that amount coming into our facility. And in order to protect the activated sludge process, we are able to take primary effluent and route it into these tanks and then store it for a period of time and then slowly introduce it back into the system after the rain event has passed. The excess flow tanks here have a total capacity of 3.4 million gallons. So that will buy us a lot of time to make plant process changes and protect our activated sludge process. So behind me we have our high purity oxygen activated sludge basins. So in this part of the process, known as secondary treatment, we are taking primary effluent, mixing it with bacteria, the activated sludge. They combine in the basin and flow through a series of 9 different cells in each of what we refer to as activated sludge trains. One train is 9 cells. Each cell has a mixer, aerator. The primary effluent and activated sludge are mixed in the first chamber. Oxygen, pure oxygen gas is fed into the headspace in that basin. As the bacteria feed on the organic materials in the primary effluent. They're producing more bacteria and then removing that organic material from the primary effluent, thereby cleaning it up. As the bacteria use up oxygen, more oxygen is introduced into the system to keep the process going. So the primary effluent generally takes about 4 to 6 hours to make its way through the system. At the end of the process, the digested activated sludge, or mixed liquor as we call it, is distributed into 4 primary or final clarifiers. The solids, the microbes are settled out. Those are returned to the start of the activated sludge process. Some of that activated sludge is removed from the system as what we call waste activated sludge. We are constantly feeding the microbes a supply of food, and so that population is building and building, and so every day we have to remove some from the system to keep that population in balance. So the majority of the microbes are returned into the system and start the process again, but a portion are removed from the system as waste activated sludge. The waste activated sludge is pumped up to a holding tank where it is then mixed with some polymer and run through a rotary drum thickener. So that rotary drum thickener is concentrating that waste activated sludge from about 1.5% solids up to about 5% solids. At that point, it becomes thickened waste activated sludge. That thickened waste activated sludge is introduced into our blended sludge tank for eventual anaerobic digestion. After the activated sludge process is completed, the digested activated sludge enters final clarification. So behind me we have one of our final clarifiers. The activated sludge enters the clarifier through a tube in the bottom of the tank, comes up through that tube and then gets dispersed throughout the clarifier. Once the activated sludge enters the clarifier, it goes into a stilling well that helps dissipate the energy in that clarifier. We have a couple hours of detention time where that energy dissipates and the solids and liquids start to settle. The solids are collected at the bottom of the clarifier, and that becomes return activated sludge. So we're taking those bacteria, microbes, to the start of the activated sludge basins again, and then the clean water that has risen to the top of the clarifier becomes what we call supernatant or final effluent. That final effluent goes down to the ultraviolet disinfection process for disinfection prior to releasing the water into the river. Once the final effluent leaves the final clarifiers, that water then comes to our disinfection process. We are using ultraviolet light to disinfect that treated effluent. The effluent flows through a series of light bulbs that are emitting ultraviolet light. That ultraviolet light disrupts the genetic material of the microbes and therefore sterilizes them. They're not able to reproduce. After disinfection, the final effluent flows over what we call a cascade aerator that helps oxygenate the water, and then the treated effluent flows by gravity out to the Mississippi River, which is our receiving stream. So at the Water and Resource Recovery Center, we are taking natural processes and replicating those. We are taking these natural processes, settling or deposition, digestion, using microbes to degrade the organic material, and then also the ultraviolet disinfection, similar to what we see from the sun every day. So we're taking those processes, natural processes, and speeding them up, doing this at a much quicker rate at our facility. So we are required to remove 85% of the total suspended solids, so the solid materials that come in the influent, and then also we're required to remove 85% of the oxygen demand. So that is the amount of oxygen required that the bacteria require for the breakdown of the organic material. We typically achieve 95 to 97% removal of total suspended solids and oxygen demand. So we're a very efficient plant, and we're treating that wastewater to a degree so we can release it back into the environment and people can continue to recreate, fish, swim out in the river without getting sick. The solid material that's collected in our blended sludge tank is then fed into our anaerobic digesters, which are right behind me. We have 4 digesters. 2 of them operate in the thermophilic range, which is about 131 degrees Fahrenheit. The next 2 operate in the mesophilic range, which is approximately 95 degrees Fahrenheit. So we're taking that blended sludge, introducing it into the anaerobic digestion process. That sludge spends on average about 40 days in the system, and in that time we are reducing the solids concentration from about 5% in that feed sludge to about 2% in that digestate or completely digested sludge. So in that 40 days, that sludge is broken apart by these anaerobic bacteria. They're taking that solid material and volatilizing it, producing what we call biogas. The biogas is roughly 68 to 70% methane and about 30% carbon dioxide, with some other trace gases such as hydrogen sulfide, so that's the rotten egg odor you sometimes smell from sewer gas, and then some other gases like siloxanes. The biogas is produced in the digestion process. We then take that biogas, run it through treatment system, which consists of hydrogen sulfide removal. Then we compress the gas to about 4 pounds per square inch. Then we remove siloxanes. So siloxanes are silica compounds that we find sometimes in bath products. They're put in there to make them slippery. We want to remove those because if we would combust the gas with those siloxanes in there, they can precipitate out inside a turbine or an engine and cause premature failure of those mechanical parts. After the siloxane removal, we compress the gas to about 90 to 95 pounds per square inch. From there, we can take that gas and utilize it in our micro turbines. We have what's called a cogeneration system or combined heat and power. We can produce electricity through the microturbines that we have here on site, and we also collect heat from the exhaust of those turbines. That heat is used to maintain the temperature of the digesters, and that electricity is used around our facility. We produce about 75% of the power consumed on site here, so we don't have to pull as much power off the grid. After the anaerobic digestion process, we are taking that digested sludge, mixing it with some polymer, and then we take that mixture and run it through a decanter centrifuge. So right behind me we have one of our centrifuges. In the centrifuge, the liquids and solids are separated. We are feeding a sludge with about 2% solids into the process, and we're removing solids at about 28% solids. The liquids go back into the treatment system and are treated by our facility, and then the solids are hauled to a holding facility on a farm south of town and land applied. So we are standing in our biosolids loadout area. Behind me, we are loading the biosolids into a semi-trailer. The biosolids will be hauled to a holding facility about 6 miles south of Dubuque, where there is a building with about 6 months of storage capacity. The biosolids will be stored in that building until the crops are out of the farm fields. Then the material will be spread onto the agricultural land, farm fields, as a soil amendment. The biosolids has a lot of nitrogen, a lot of phosphorus, and some potassium, so it provides nutrients that help offset what the farmer would have to apply in synthetic fertilizer. It also adds organic material and improves the tilth of the soil, which is the suitability for growing crops. In a typical week, we are hauling about 4 or 5 semi-loads of biosolids out to that holding facility. So each load is about 20 tons of material, wet weight, probably 80 to 100 tons of material leaving our facility per week. So I talked before about our cogeneration system and how we use the treated biogas to produce electricity and heat. We also have the ability to take that treated gas and feed it into a pressure swing adsorption system. So we are working with a company called Bioresource Development. They have installed equipment which sits right behind me, which consists of a pressure swing adsorption unit. That system is it's a series of tanks that contain a media that attracts the molecules of methane. So the biogas enters the tanks, is attracted to those molecules of methane, then there's a vacuum drawn on those tanks that removes carbon dioxide with a little bit of the methane. That vent gas goes to the flare where the methane is combusted. Then once the vent gas is removed, there's a deeper vacuum pulled on the system, then that methane gets pulled off and then compressed and then is fed as renewable natural gas into the utility pipeline. So we're actually producing utility grade renewable natural gas on site here. The local gas utility, Black Hills Energy, has what they call a town border station here, where they are constantly monitoring the quality of the gas to make sure that it meets the specifications required for the pipeline. Actually, the renewable natural gas that's produced here is very high quality. The gas utility actually has a valve that will close if it doesn't meet specifications. There have only been a few times that the valve has actually closed due to one thing or another, if the CO2 was too high or if the hydrogen sulfide level was too high. But for the majority of the time, that valve has been open, actually since I believe it was February of this year. We've been able to put renewable natural gas into the pipeline. So I'd like to thank you for joining us today. Hope that you learned about our process and gained a little insight on what it takes to treat the wastewater that is received by our facility. Thank you.